Okay, would you like to learn, enjoy, and understand the beauty of advanced chemistry? If that's the questions that you've been asking yourself, I would like to tell you that I have a good news, which actually that is going to locate you in a particular place. How are you, every national and international viewer? I'm very happy to have you today, and this is Olenjolai, Moko Tayelo Single. Simply just can call me Olenjolai. And in this moment, I'm ready to pour out what I've prepared for you. So in case that you've been asking yourself so many questions about how you can go through advanced chemistry, advanced physics, I want to tell you that in case you make serious decisions in order to learn step by step, we ask you to join us in our online school. So I would like just to share with you a few things before we start our today's session. Firstly, I would like to introduce to you that I will be your chemistry teacher in advanced chemistry, Form 5 and Form 6. However, today we'll be focusing on the Form 5. I am a Tanzanian, and this is our national flag. However, that the programs we are not doing only for the Tanzanian students, but we are doing for all the advanced secondary students in the world. We'll be using the syllabus of United Republic of Tanzania. So if you are a Form 5 students or Pre-Form 5 students or Form 6 students or Pre-Form 6 students, make this to be home of learning anywhere at any time. So our main objective in our online schools is to teach and train advanced secondary students to master, enjoy, and apply these advanced subjects in solving real-life problems. So, just I still have few things to share. If it's your first time, or maybe it's your second time or third time, I won't be tired to welcome you into our Tanzania Online Advanced Secondary School in square bracket Olenjolai. Simultaneously, we have our official YouTube channel where we used to publish different videos of advanced chemistry, advanced physics, advanced mathematics, and basic applied mathematics. So you're only welcome into Tanzania Online A-Level Secondary School in square bracket Olenjolai. So if you want to access our previous contents or you want to access our future contents, we ask you to visit just our official YouTube channel. Just to go into the YouTube applications, then you write Tanzania Online A-Level Secondary School in square bracket Olenjolai. Another thing that we like to insist to you, in order for you to get notifications whenever we add any new video or any new information in our official YouTube channel, we ask you to click the button of subscribe in order for you to receive notification from the YouTube community. We have more than 3 departments. One of the departments is called Advanced Chemistry, so you're all welcome. And the subject of the day is called Advanced Chemistry. And the main topic that we'll be focusing today is called the Organic Chemistry, or we can call it Advanced Organic Chemistry. And this contest we dedicate to all the Pre-Form 5 students, Form 5 students, QT students, Grade 12 students, for those who are in English medium, visitors who are receiving the Form 6 exams, which we call the Advanced Certificate Secondary Education Examinations in Tanzania. But in Kenya, it has a special name, in Uganda, in South Sudan, so they have a special name. But also like to dedicate this contest to the teachers who teach chemistry in this level, because even myself, I used to learn from other teachers. So today, it means that in this main topic of organic chemistry, we'll be focusing on the second topic that's called saturated and unsaturated hydrocarbons. And this is session 12, which is titled as Laboratory Preparations of Alkanes. We need serious students. We are very serious, and we are here in order to help you and answer so many questions. Okay, before we start today's session, I would like to invite you again on how you can ask questions, because we like to interact with our students. So these programs you are taking it online. We are not physically together, I and you, but we can interact through the online. So the YouTube community has created the platforms where we can interact with that called the comment sections. So you can ask your questions in the comment section. You can give us testimony, you can give us feedback, you can give us your recommendation, you can submit your homework. So actually, do whatever you want in the comment section, because we used to read it and we'll be trying our level best to answer about what you've been asking in the comment section. But again, comment sections is public, so even if myself I won't be able to answer your question, some other students around the country or across the country of Tanzania or even worldwide, they can answer your question. All right? If at the point I believe that you are ready and you've got some ABCD in order for you to be a serious student. So right now, just to take your pen, take your exercise book. There's no need of scientific calculator, maybe in the lecture in session 13, where we can have some kinds of calculations in case of the chemical reactions of alkane. So let us start with the part we call it a quick review. Quick review of what? Quick review of session 11. If you've missed the session 11, you can access in our official YouTube channel. You have just to search it. And once you are in TANZANIA Online A-Level Circuit School in square bracket Olenjolai, then we can go into the playlist or the playlist for Advanced Organic Chemistry. Then check for the session 11. Go through it before session 12, because in session 12 depends to what to session 11. So quick review of session 11. So in session 11, basically we reminded you about definition of what. So mind about definitions of, just the simple definitions of alkane, what the meaning of alkane. So definition of alkane. But again, we reminded about the molecular formula of alkane, which is CnH2n plus 2, right? And then we taught you about laboratory preparation of what? Of alkane. So about preparations of what? Of alkane. So we say we began with the first method or first category. We say that lab preparation method, which don't alter or don't change number of what? Number of carbons. And then we have discussed in detail. The first one, we say that hydrogenation. So hydrogenation of what? Of unsaturated hydrocarbon. Then the second reactions, we taught you about hydrolysis of what? Of pregnant reagent. So pregnant reagent. So hydrolysis of this one can prepare also alkane. Then I taught you about reduction of what? Reduction of carbonyl compounds. Reductions of carbonyl compounds. So we say carbonyl compounds, it means aldehyde and ketone. Then I left the homework 61, homework 11.1, I think homework 11.1 or 11A and B. And I think that you have done everything well and you've submitted your work in the comment section. Sometimes, the good thing for the chemistry, you can write the molecular formula, but it's a little bit challenging in the comment section. Comment section is not efficient for the science, for the most of the science subjects. I'm still praying to God the alternative platform where I can interact with students. Because, for example, if you want to write the open structure in the comment sections, it won't be possible. So keep waiting. Later on, I will share to you about another platform where you can attach your file. So let us continue with this part that we call the reactions, which do not accompany the change in the number of carbon atoms in the molecule. So we ended number 3. So let us go into the fourth reaction. Okay, so this is number 4. So this is today's session. So the fourth reaction, which do not change the number of carbons, is called the reduction of alkyl halides. Reductions of alkyl halide. Reduction of alkyl halides. Reductions of alkyl halides. In presence of what? In presence of metal and the acid. presence of 40 of metal and the acid. So the actions of alkyl halides in presence of 40 of metal and the acid. So this is the name. So reactions of alkyl halides in presence of 40 of metal and acid. So reduction, remember that we say that reactions, it's a chemical reactions which reducing what? The number 40 hydrogens in most cases. There are three definitions of reaction, as long as there is also three definitions of oxidation. Right? Yeah. So it means when you say reduction, we are reducing something in alkyl halide by the means of reduction. Okay? And you have to make sure that you differentiate reduction and elimination or substitution. Because in organic we have different terminology. We have reduction, we have substitution, we have elimination. So you have to understand them, what the difference between them. So you say that so simply say that alkyl halide, we say that alkyl, say alkyl halide. So you say alkyl halides, it means that halogens attaches to the organic compound. Alkyl halides can react. So alkyl halide can react with zinc in the presence of 40, in the presence of acid, to form what? To form alkane, and what? So to form alkane and the zincy halide. Alkane and zincy halides. Zincy halides. So these are the end product. So generally we say that on reactant side we have alkyl halides. We have alkyl halides react with zinc, and then the product is alkane, then plus what? Plus zincy halide. Okay? So this is the general, or we call it the word equation. So remember that this is the wordy chemical equation. So by using the overall, or just to call it, yes, the general molecular formula, the alkyl halide is presented by R. Remember that R represents hydrocarbons. Then the halogens is presented by X. Okay, so you have basically four halogens: fluorine, chlorine, bromine, and the iodine. So it's presented by X. So if this one will be reacting with zinc, then under the presence of hydrochloric acid, so here under the presence of hydrochloric acid, then the product is what? Is R, then bond with hydrogen plus zinc halides. Okay? So, examples. Reactions is simple. Examples. So the first example, we say that you can have chloroethane. Okay, chloroethane reacts with zinc under presence of hydrochloric acid. The product will be what? So simply chlorine is going to break down. Okay, so listen careful. So if this chlorine, so it means that it's simply what you said, the simple mechanism for you to understand what's going on. So we have CH3, or we have bond between carbon and carbon, bond between carbon and the hydrogen, 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 hydrogen. So then this is what? Chlorine plus what? Zinc. Under presence of what? Hydrogens will form hydrogen ions, and then chlorine will form negative ions. Okay? So Here we have covalent bond between carbon and chlorine, which is more electronegative, it's chlorine, right? So chlorine is more electronegative compared to carbon. So the bond will break in this way. So if that bond will break, on this side you have CH3, here you have hydrogen bonds with carbon, here you have partially negative, then you have what? Zinc, but zinc also has to ionize to lose 2 electrons. Because zinc atom or zinc metal is unreacted, it's neutral molecule, right? So then, why hydrochloric acid is decomposed into hydrogen ions and chlorine. So for this case, you find that this is acting as electrophile. So the nucleophile, we used to draw arrow from where? From nucleophile to electrophile or electrophile to nucleophile? Huh? Electrophile to nucleophile. Huh? Nucleophile to electrophile. Like this. Okay. And then this chlorine, we have another one, chlorine. We have chlorine somewhere else there. Forgot one chlorine. So then this is what? This is chlorine. Partially negative. Plus what? Zinc, but I said zinc has to ionize by losing 2 electrons. Here you have what? Hydrogen ion, chlorine ion. So we say that this nucleophile will be reacting with electrophile, and then this nucleophile or this guy will be also reacting with this, and also the other ones will be reacting with this. So that's why the end product now, so we have CH3, we have CH2, chlorine, and then that's what is zinc, and the presence of 40 of acid, which hydrochloric acid, this will form what? This will form 2 carbon, 6 hydrogen, plus what? Zinc chloride. That's the overall, this we call it in chemistry, overall chemical reaction. So overall reaction. Okay? So that's how the business goes. So now the quiz. Complete research, complete this mechanism. Don't think that different concepts of organic are simple in this way. Okay? But I left my homework yesterday. I have some students in this class. They didn't show me whether they succeeded. Possibly they forgot it. They found themselves that they're in the class, but they did nothing. So bromine plus zinc and the presence of 40 of hydrochloric acid. So that's the simple quiz. I know my senior students can solve that problem immediately as soon as possible. Okay, so that's all about reductions of alkyl halides in presence of metal and acid. The fifth chemical reaction that prepare alkane in laboratory without reductions of number of carbon is called hydrolysis of aluminium carbide. So I taught you in hydrolysis of aluminium carbide. Hydrolysis of aluminium carbide. Hydrolysis of aluminium carbide. So in session 11, I taught you the meaning of hydrolysis. After I taught you the meaning of hydrolysis, then I taught you hydrolysis of 40 Greenland reagent. Today, we have to learn hydrolysis of aluminium carbide, which is used to prepare alkane. So hydrolysis simply means that this is the chemical breakdowns when a chemical substance reacts with water. Okay? So you say that aluminium carbide can react with water to form what? To form alkane. So for this case, we say that general wet chemical equation is given as this one. So here we have aluminium carbide as a reactant. Aluminium carbide reacts with water. Then the product will be alkane. Alkane plus what? Alkane plus aluminium trioxide plus aluminium trihydroxide, so plus aluminium trihydroxide. Okay. So you say aluminium carbide. This is compound made by aluminium and rotting and carbon atom. So aluminium compound, it's a compound made by aluminium and the carbon atom. So not before, because I know for many advanced secondary students, aluminium carbide it's a new compound for them. So you say aluminium carbide. Aluminium carbide is so aluminium carbide is made up by aluminium and the carbon. Aluminium and carbon. Okay, so look at the case now. Let us see example. We have aluminium carbide. So the compound, the aluminium carbide, is written according to how the chemical reactions is formed. So remember that the carbon has 4 valence electrons, while aluminium has 3 valence electrons. So it means that carbon can lose 3 electrons, while aluminium can lose 3 electrons, while carbon can save 4 electrons. So if you say that if you cross like this one, so that's why that you find aluminium 4 atoms of aluminium are required to react with 3 atoms of carbon. Okay, so this is what we call the aluminium carbide. So now the chemical reaction, we say that we have aluminium carbide, which is this one. So there's no need for you to cram. You just have to remember what we taught you about formation of the molecule in Form 2. Okay, so we say that here, under presence of what? These reactions take place in order to form what? Methane. You have 3 carbon atoms, but the end product here, in most cases, is methane. Then we say methane represents what? Alkane. Remember the general word chemical equation. We have alkane and aluminium trihydroxide. So also we have what? We have aluminium trihydroxide. But did we balance the number of carbon? No. Here we have 3 carbon atoms, here we have 1 carbon atom. So we have to introduce 3. Do you balance the number of hydrogen? No. Here you have what? You have 12 hydrogen plus these 3 hydrogens makes 15 hydrogens. Okay? Make 15 hydrogen. So we have to balance because it's the chemical equation we have there on the blackboard is unbalanced. So to balance, on this side we have added 3. So 3 times carbon to 3 carbon atoms, and 3 times 4 makes 12. Then 12 plus 3 makes 15. So how can you balance with this? Again, that will be a challenge. Because if we introduce 6 here, we get 12 hydrogens. If we introduce 7, we get 14 hydrogens, which is still less than the number of hydrogens on the product side. So the best way, I have also, so here I have 12 hydrogens. So the best way to balance, I have also to increase the number 40. I have to increase the number of aluminum atom, the number of oxygen, and the number 40 of hydrogens. So at this moment, I have 12 hydrogens in this compound and 12 hydrogens. So it means that in order to have or to balance the chemical equation, I have here to introduce 12. So 12 times 2 makes 24. So the number of hydrogens is already balanced. But how about the number of aluminium? So you have 4 atoms of aluminium, 4 atoms of aluminium. Right? 3 atoms of carbon, 3 atoms of carbon. But here we have 3 atoms of oxygen. No, we have 3 atoms of oxygen times 4, which makes 12, 14 atoms of oxygen. And even here we have 12 times oxygen, so the equation says already be balanced. Right? So it's a single, we don't have any other chemical reactions, it's only this one. So it means that this method prepare only methane. Okay? So you say that hydrolysis of, so this you have to note again, hydrolysis of aluminium carbide, okay, prepare what? Prepared only methane. Prepare only methane as we have discussed. Okay, so at this moment we have learned how many methods of preparing alkane in laboratory? 5 methods. And these methods are very important because, for example, you can be given a question which you have to convey maybe aluminum carbide to become aromatic compound. So you have to know the steps that you have to follow. Right? Okay. If you have any question about what I'm teaching you or about laboratory preparations of oxygen, don't hesitate asking in the commenting section of this video. So that's all about the reactions or laboratory preparations of alkane, reactions that prepare alkane in laboratory without changing the number of carbon atoms. So now let us go into the second category, which I can call it B, say that a chemical reaction means that reactions that reduce the number of carbons. Reduce the number of carbons. Use the number of carbons in the molecule. The good news also, this is only the molecule. This is only one method that can reduce the number of carbons. It can prepare alkane, but with less number of carbons compared to the number of carbons in the compound. So reaction which involves decrease in the number of carbons. So this one is called the decarboxylation of the sodium carboxylate. So this is the sixth method. It's called the decarboxylation. Decarboxylation of what? Of sodium. Carboxylations of sodium carboxylate. Decarboxylation, say it with me. Decarboxylation, say it, because when you say it, you write in your mind. Decarboxylation of sodium carboxylate. So the carboxylations of sodium carboxylate. Decarboxylation of sodium carboxylate. Sodium carboxylate, it's a salty, it's a weak salt because the acid used to form sodium carboxylate is weak acid, which is carboxylic acid. Right? So it's a weak salt. Okay? So we say that when sodium Okay, so we say that when sodium carboxylate, salty, reacts with what? React with sodium hydroxide under the presence, in presence of what? In presence of calcium oxide as catalyst, presence of calcium oxide as catalyst, and the heat, then Alkanes, with few number of carbons will be formed or produced at the point. So it means that the carboxylations of sodium carboxylate, it's one of the methods we use in chemistry to prepare alkane. And this method just needs two reactants. The first reactant is called sodium carboxylate salt, which is it's a weak salt. And the second reactant is sodium hydroxide. So we need sodium carboxylate salt, and also we need sodium hydroxide. But what the catalyst required is calcium oxide as the catalyst that required. And what the condition means that the reactant should be heated in order to speed up the reaction. Then alkane with few number of carbons compared to the reactant, we compared the number of carbons in sodium carboxylate will be formed. Okay? So the general weight chemical equation is given as what? So here's sodium carboxylate plus sodium what? Sodium hydroxide. You should not claim this stuff, but under presence of what? Calcium oxide and heat. The product will be alkane plus what? Calcium carbonate. No sodium carbonate. No sodium carbonate. That's what should be in your mind. Even if you forget the rest piece of information, if you keep this stuff, you are done. So, we say that we need sodium carboxylate. So we have to know something called functional group, something like functional group. I will check this name. We have a special name that we use to call this stuff. Okay, so the functional group or the general molecular formula of sodium carboxylate, HC hydrocarbons, means that a part of the compounds formed by carbon and hydrogen only. Then we have one carbon which will form a double bond with oxygen. Then there's a single bond between carbon and the oxygen, and this oxygen will form a bond with sodium. So this is what we call the sodium carboxylate salt. So it means that if this one is CH3, then it's called the sodium ethanoate salt, right? If it is TH2 or CH2H5, then that is what sodium propanoate salt. So this is how organic chemistry flow. Okay, we are still in the fundamental concepts of alkane, but you can notice that we are learning even some other concepts that will cover them in future. Okay, because when I will teach about the preparations of carboxylic acid or chemical reactions of carboxylic acid, one of the chemical reactions of carboxylic acid is what the carboxylations of sodium carboxylate. Right? So it means sodium carboxylate can undergo decarboxylation. Decarbo, it means decrease. Decarbo. So carbo stands for what? Carbo. Right? Decarbo, decrease. Decrease in what? Number of 40 of carbon. That's what it means of decarbo. Okay. So then we need what? We need sodium hydroxide. We know its molecular formula. See this one. Okay. What the condition? Conditions is presence of calcium oxide. No, catalyst is calcium oxide and the presence of heat. Then now what will be the product? The product is alkane, right? So alkane does not contain carbon with double bond with N oxygens. And alkane does not contain N oxygen. Alkane contains only what? Carbon and the hydrogen. So, my dear student, these reactions, what is going to actually mean that one hydrogen is going to replace sodium, oxygen, carbon, and oxygen. So that hydrogens will be attaching here. So simply listen. So the bond which is going to break is between hydrocarbons and this functional group of carboxylic salt. Wonderful? Yeah, that's how. This is the way that God used to teach me organic chemistry. If you want to give you a testimony how did I understand organic chemistry, it's a long story. Because I've been taught by different people, but really, they are teaching me how to cram. So unfortunately, I failed how to cram. So I've been thinking myself outside the box, what's going on here. Regardless that questions will appear in exams, but I want to understand. That's a simple way for me to remember, right? So, if this is the case, this is alkane, and then she said another end product is what? Sodium carbonate. So, do you remember the formula for sodium carbonate? Sodium ionized by losing what? 1 electrons. While carbonate can gain how many electrons? 3 electrons. 2 electrons. Okay, so 2 electrons. That's why this becomes sorted. We need 2 atoms of sodium to react with carbonate to form a neutral compound. All together. So if that's the case, this is general, regardless of whether this is branched alkane or maybe because in most cases when we branch the alkane or unbranched the alkane. So this is the general formula. So regardless of how many number of carbons. That's why that I'm teaching you these fundamental concepts in every reaction. So regardless that here you're being given, maybe if it can be given 5 number of carbons and some number of hydrogens. So the same principle, right? That's we call it in general, or we call it overall chemical equation. And its mechanisms is very simple. Okay? Okay. So if this is the case, listen careful. So let us see an example. Okay, an example, say that completing the reaction below. Okay, complete the reaction below. So we can have also an organic compound, which is like this. Listen careful. Here we have carbon, we have hydrogen. So this is branched. This is not the benzene. It's attached group, right? And then here we have sigma bond. Then we have this oxygen. We have bond with this hydrogen like this. With sodium here. Then plus what? Sodium hydroxide. Sodium hydroxide. So it means that sodium hydroxide, you know what's going on. Sodium has formed a bond with oxygen, but oxygen also has formed a bond with hydrogen. Right? That's the meaning of sodium hydroxide. So what the condition is, what the catalyst here, calcium oxide. Condition and the presence of heat. So complete it. I've written the open structure to just to help you. So solution for this simple problem, we say that here we have branch D. This equal to we used to, if this system itself we used to call it benzene. How do we call it if it is attached? Because here benzene is attached in benzene represents R because benzene contains carbons and hydrogen. Right? Benzene contains how many? 6 carbon and 6 hydrogen. Right? So it's presenting R. So you should not think that this is all about aromatic. No. Right? Okay. So in the case we have this guy, we have hydrogen here, we have hydrogen here, we have a bond, double bond with oxygen, then here we have a single bond with oxygen, then this is single bond with sodium, then plus what? Plus sodium, this is oxygen, this is hydrogen, then under presence of what? Calcium oxide and heat. Okay, so how the reactions is going to take place? Okay, so here the reaction, the way it's going to take place, we say that the bond is going to break down in this direction. The electronegativity between these carbons and this carbon is the same. But remember, these carbons will have a tendency of, it means these electrons will be too much attracted by this oxygen because oxygen is more electronegative and also it contains love pair. Right? So the bond will break in this way, but also here the bond will break in this way. Right? So this one will be partially negative, and this one will be partially positive, while this one will be partially positive, and this one will be partially negative. Are we together? Are we together? Alright. So if that's the case, you say that this guy, then this carbon, you have one with hydrogen there, and we have this guy. So we have what? Partially negative plus what? Carbon, which is partially what? Partially positive. But we have how many carbon? How many oxygen? We have 2 oxygen and sodium, like this. Then plus what? Plus sodium oxide, but partially negative. Plus what? Hydrogen partially positive. And the conditions of what? Calcium oxide. Then here heat. So means that the nucleophile will react with the electrophile to form a new bond. And this nucleophile will react with this electrophile to form a new bond. Right? So the end product now is this guy. This guy has carbon, hydrogen. We have what? So this is hydrogen plus what? Plus, so what's going to happen here? You see now, how many number of oxygen? So we have 3 oxygen, right? 1 carbon, 2 atoms of sodium. So everything is well. So this is sodium carbonate, an end product. You see how organic chemistry is beautiful? Do you see how organic chemistry is beautiful? To me, it's beautiful. I don't know about you. On your side, you can tell me in the comment section. So, simply, the overall reaction, overall chemical reaction is, we have this organic compound, then this guy have 2 hydrogen, which is sodium what? Sodium benzanoate. Sodium benzanoate, when it reacts with what? Sodium hydroxide, under the presence of which catalyst? Calcium oxide, and heat is from what? From this guy. Like this. So here we have alkane plus what? Sodium carbonate. Okay, so that is all about Choti. So homework 12, complete. This mechanism, the reaction below. Okay, very simple question for my serious student. It's a very simple question. Okay, so this is the 6th method of preparing alkane in laboratory, which decreases the number of carbon in the organic carbon. Let us prove if it is true. How many carbons do you have in these aromatic compounds? 6 carbon, right? Plus this one, 7 carbon. Plus this one, 8 carbons. So in the reactant side, we have an organic compound which contains 80 carbons. While the product contains how many electrons? How many carbons? 1, 2, 3, 4, 5, 6, 7. Only 7 carbons. So this is the carboxylations of sodium carboxylate salt actually reduces 1 number of carbons. So remember that, my dear student. Remember, these reactions is very important when you'll be doing or answering questions of conversion. Listen carefully. So whenever you find a reactant, or whenever you find a question which asks you to convert the organic compound from one state to another. I know some of the students are busy on doing homework 12. Listen. Sometimes you can find that you'll be given maybe carboxylic salt. Or maybe in a certain, maybe in stage 2 or stage 3, you find that you form the carboxylic salt. And then maybe the end product or the next, it means that the intermediate product in the next stage does not, maybe contains few number of carbons. So from there, if you have carboxylic salt, and then you want, it means that the intermediate state, you want to reduce the number of carbons, or maybe the end products has less number of carbons, then you have to remember about the carboxylation of 40 sodium carboxylate salt. Are we together? Many students, they face so many challenges in conversions because they have few alternatives of preparing a compound. Even myself, I learned Alkane when I was in ordinary secondary education. I learned Alkane from different resources. But sometimes I used to find some questions and then I used to fail to answer them because I have few alternatives. Okay? Okay. So that is B. So C, let me present to you or teach you, my advanced secondary students, reactions of what? Reaction that increases what? Reaction that increases the number of carbon. So when we are preparing alkane, some of the reaction, or when preparing alkane, some of the method can increase the number of carbon compared to the reactant. Okay? So reaction that increases the number of carbon. Reactions which involve the increase in the size of carbon or the number of carbon. So this will be the 7th method of preparing alkane, which is called the Woods reaction. So Woods reaction. Woods reaction. So Woods reaction. Woods reaction. So this is the 7th and the last method of preparing alkane in laboratory. Okay? But this doesn't mean that all of this, there are only 7 methods of preparing alkane. But this is what I've prepared it for you. Okay? So you have to make sure that you learn different methods of preparing alkane as well as we can. The fundamental question, first of all, we want to understand what does this reaction mean? What is Woods reaction? What is Woods reaction? What is Woods reaction? Okay? So we say that Woods reaction is a reaction between alkyl halides and sodium metal. So Woods reaction is a reaction between alkyl halide and the sodium metal in the presence of what? In the presence of dry ester, in the presence of an ester, the presence of an ester, to form what? To form alkane is double size. It's a very important chemical reaction in organics. Double the number of carbon atoms, so double size. So you say double size, it's well understandable. So you say, what is Wood's reaction? So Wood's reaction is a reaction between alkyl halide and sodium metal. So simply this is the reaction between alkyl halide and sodium metal in the presence of an ester to form alkanes double size. What does it mean? It means if the alkyl halide contain two, or if an alkyl halide contain one carbon, when it undergoes Wood's reaction, the number of carbons will be increasing from 1 to 2, right? If alkyl halide with 2 carbon atoms undergo Wood's chemical reaction, then the number of carbons and hydrogens will be doubled, right? Right? So if it contains 2 carbons, the number of carbons after the Wood's reaction will be 4. Right? If a dump an alkyl halide with 3 carbon atoms undergo Wood's reaction, the number of carbon is going to double and becoming what is 6. Right? Right? All together. So that the point that you have to understand. In these reactions, just we understand what's going on, but yeah, we understand what is going on. So say that the necessary condition for this reaction to take place is warm temperature. Warm temperature. So the condition for this reaction to take place is warm temperature. Okay, so the temperature is 1. And remember the catalyst is what? It's ether. So if that the case, you say that the general overall, the general wet chemical equation is this. So you have alkyl halide plus what? Plus sodium metal. The condition, the catalyst is ether. Then the condition should be warm. Then the product will be double size of alkane plus what? Plus sodium what? Sodium halide. Sodium halide. Alkyl halide, so it means that the functional group is X plus sodium metal, but we should have 2 atoms of sodium metal. When this one undergo or is warmed under presence of what? Of dry ether, then the product will be 2 atoms. So So here we need 2 atoms of alkyl halide. So we'll be having what? Double size of what? Yeah. So plus what? Plus 2 atoms of sodium chloride. Oh, 2 atoms of sodium halide. So this is overall reaction. Okay, so if the case, so the mechanisms is very simple, the way it is. What is going on? You have to understand the process that is going on. The mechanism is this. We have hydrocarbons attached to this halogen. Then you have sodium atoms. Sodium atoms undergo ionization by losing 1 electron. Right? So, because of the nature of the reactions, we need 2 atoms of sodium ion. And here we need 2 molecules of what? Alkyl halide. How the bonds break down. So this is more electronegative. Halide is more electronegative. Halides are more electronegative compared to carbon. So this one is partially positive, and this one is partially negative. Okay? But we say again, we need what? We said that you need dry ether. Ether also contains what? Hydrogen. So it means the dry ether will just give us 2 hydrogen atoms. Right? So this is what? Ether, and then 1 temperature. So it is bond breakdown with 2 atoms of other, partially negative, plus 2 atoms of what? Of halides, plus what? 2 atoms of sodium, then plus 2 atoms of what? Of hydrogen. So if that's the case, nucleophile will react with electrophile, and then this nucleophile, 2 atoms of nucleophile react with this one. So for our reaction, we say that we have 2 atoms of alkyl to balance the number of atoms, plus what? 2 atoms of sodium metal. This one will form what? And the presence of what? Dry ether. Then we have what? 1 temperature. So this is RH plus what? Plus sodium what? Plus 2 atoms of sodium. Yes. Okay? So, if that's the case, let's see example of what's the reaction. Complete the reaction below. Complete and balance the chemical reaction. Remember, sometimes the questions does not ask you to do the mechanism, but we teach our students mechanism of different chemical reactions in order for them to understand. Right? So we don't mean that you'll be asked about the questions concerning about church. Maybe we ask the question, okay, fine. So the chemical reactions mechanism. So in most cases, we ask just complete the reaction. And sometimes, if the mechanisms is not, the condition of mechanism is not given, you may even do your mechanisms on graph paper and then write the right. Okay? Yeah, so that the trick you have to remember. So if this is the case, if this guy, so remember the mechanism, what is going on. So simply the product will be this branched circular compound. So here what? CH2, CH2, CH3. Then plus what? Sodium. Is sodium bromide? No. Sodium bromide. Remember that this we said it will double. Okay? So if it will double, you have to understand, listen carefully. So the way this one is going to double, this part R is the one that is going to double. Okay? Okay? It's just like here. So you have Rx, X, it won't be, even it's not, later on it will be inorganic compound. So it's not the organic compound. So you see here R double. So what is R representing? R representing this cyclopentane, but then this part and this part. Okay. Okay. So how the double, or how the size of carbon will increase. If you check this one, okay, and even just okay. So if we give you an example, you can do the comparison. Huh? So solution. Okay? So the solution we say that, okay, listen careful. This guy will duplicate. Okay, so with this one we say that CH2, then CH, H. Then carbon, CH2. Okay. Wait a moment. CH2, see that one. Okay. Yeah, wait, this is CH2. Then this is CH2. Or simply let me like just open structure. My students will understand it easily. Okay. Then prolactin. Then this molecule will be double, right? So what does it mean? What the meanings of double? I think here even there's no need for hydrogen. Okay, correct it. I made a mistake. There's only the hydrogen here. Okay, so simply when you see this part, you'll find, okay, so this is R. Okay, so if the number of carbons, so you say the size of the compound is going to double size, we expect to see something like this. Are you together? So what's going to happen? Because you have 2 atoms of what? Of this organic compound, but those 2 atoms of organic compound can be used effectively. Okay. How? Listen carefully. So the next molecule will be carbon bonding with hydrogen, and this one bonding with hydrogen. Next molecule will be carbons bonding with hydrogen, bonding with hydrogen. The next molecule will be cyclopentane. Plus what? Plus sodium chloride. Balance. We have 2 molecules, we have 2 atoms, we have 2. Okay? So listen, product side, how many number of carbons do you have? Stop writing. How many number of carbons do you have? 1, 2, 3, 4, 5. Right? 6 is 7. Right? In our product, how many number of carbons do you have? 1, 2, 3, 4, 5. Okay? 7. Right? 8, 9, 10, 11, 12, 13, 14, 15. Are we together? Are we together, or should I add another example? Huh? There are 14, huh? These are 5, 7. These are 5, 7. These are 5, 2. So 7, 7, 14. While in the reactant side, we had what? 5, 6, 7. So the number of carbons is what? The number of carbon is what? It's doubled. Right? Are we together? Okay. So suppose that this is example 1 or question 1. Question 2 can be given a simple fatty compound. So plus sodium, but 2 atoms, and this one should be 2 atoms. This will balance yourself. Huh? Under presence of 40, under presence of ester, then 1. Okay? So with this one, you have to remember that, as I told you. You have 2 atoms here and 2 atoms here. Okay? Okay. So listen, the bond that's going to break down is between carbon and the chlorine. Okay? Are we together? Okay, fine. So now the end product here will be what? This is CH3, CH2, because you have 1. So CH2, and then you have what? CH2, then you have what? CH3, plus what? Plus sodium. Sodium. So you see the number of carbons. So here we had 1, 2. Here you have 1, 2, 3, 4. Right? So if you compare 2 and 4, this is double. Are we together? And you say that now the homework. Homework what? Homework 12. Complete the following reaction with mechanism. The following reaction. So I believe that these are very simple questions because I've been teaching you the way that these reactions used to take place. And this is the seventh method of preparing alkane in laboratory. And it's enough. So you may go further as well as you can in case of laboratory preparations of alkane. And I told you one of the advantage, you'll understand the alkane, but the second advantage, also when we're learning different methods of laboratory preparations of laboratory preparations of alkane, then at the same time we are learning also about chemical properties of other compounds rather than alkane. So ladies and gentlemen, this is the end of session 12. I would like firstly to invite you in session 13 when I will teach you just in a few minutes about physical properties of alkane, but I'll be focused on chemical properties of alkane. So stay tuned. Remember that to subscribe into our official YouTube channel for you to get notifications, and also remember to check some guidance or some instructions that will help you to go into the playlist of advanced organic chemistry. So before I end this session, I would like just to share with you a few announcements. The first important information we ask you that to use the comment sections to give us feedback, whether you have understood or maybe you have been confused about what you are doing. But if you have begun with session 00, which is general introductions of organic chemistry, and then you have been going or you've been learning organic chemistry sequentially, I believe that every piece of information I'm sharing to you right now, it's simple for you to carry it out. But if you made it session 12, you should not be confused. You can access session 0, session 1, 2, 3, 4, 5, 6, 7, and 8. You'll be finding the missing session in session 9 and session 10 at this time. And you can access all the contents in our official YouTube channel that called TANZANIA Online A-Level Circuit School, OLENJOLAIM. We ask you to watch this video several times as well as you can, so that this information will be written in your mind and give us the feedback in the comment section. Another announcement, in case you feel from your heart that you want to offer our God, our living God, because you can offer also some other gods, but we have only one living God. You are feeling thanksgiving, so the telephone number written here, Sadaka, which is 0759745331. You can send your feeling thanksgiving of an amount of 100 shillings or 500 shillings or 500,000 of 1 million, and your feeling thanksgiving will be used effectively to pay for the running cost for this program, because I told you in the previous session, but I'll be reminding you, we have a vision of recording 600 videos about advanced physics, advanced chemistry, advanced mathematics, and basic applied mathematics in Form 5 and Form 6, which makes a total of 80 subjects. So it's very expensive in case of time, energy, and all other aspects, including financially. So your feeling thanksgiving will be used to pay the running cost in order to make sure, it means that in order to accelerate me, to make sure that I have to pour out all of those more than 600 videos in order to help present and future generation. Lastly, we ask you to invite some other students in order to enjoy the beauty of advanced organic chemistry. We are just into session 12. We still have so many sessions ahead of us, but we ask you also that you can order the notes, because I have the notes for organic chemistry, which actually can help you. And how can you order either notes or the books of advanced secondary chemistry or advanced chemistry? Then the only method right now, you can use the telephone number 0759745331 and just to send a message, because you can make a call and nobody can be picking your phone, or you can find that it's not reachable in most of the time when I used to record or I used to teach these sessions, right? So make sure that you may order your book or the notes in order for you to go far as well as we can. This is the end of session 12. I thank you very much. Welcome into session 13, which is actual, that will be recorded, will be taught and well recorded soon. So may God bless you. This is Olenjolai. I love you so much. Keep enjoying the beauty of advanced chemistry. See you in the next session. Be blessed.